coming out. This is the Historical Society's History Bites series. And my name is Bonnie Isman. Nice to see everybody here. So today's topic, obviously, is Tan Brook. We're very pleased to have someone to guide us through an exploration of this brook, which starts up by the Wildwood Cemetery, as I understand it, and then kind of disappears. It's underground, it pops up, it goes underground again. And so we'll find out what has happened to Tan Brook over the decades past. And here to tell us about Tan Brook is Dr. Christine Hatch. We're pleased to have you. She's the Extension Professor of Water Resources and Climate Change in the Department of Earth, Geographic, and Climate Sciences here in Amherst at the University of Massachusetts. And she serves on the Massachusetts Water Resources Commission and as Research Extension Liaison for the Center for Agriculture, Food, and Environment. She's also currently an Associate Editor of Water Resources Research. So we couldn't have a better guide, and I'm going to turn it over to Christine Hatch.
Can I ask you to dim the lights on the screen, please?
Yep.
Thank you so much. So welcome, everybody. Thanks again for coming along on this tour of the Tan Brook with me. And this is a little bit of an unusual map. Most people don't look at the world this way, but I look at the world this way because it's river-centric. And so my tour of the Tan Brook is going to be river-centric. So we'll start with a few labels just to start getting you oriented. So the Tan Brook is there on the right, and the flow starts on the right and moves towards the left as it moves from the Tan Brook into the Mill River and then eventually off to the Connecticut River. And I'm using this framework to give you benchmarks for what I'm going to talk about. So we'll start out with following the watershed. I'm going from, again, right to left. First, how I got acquainted with the Tan Brook, because as our introducer pointed out, it's not immediately evident when you come into town that there's even a brook here. And then I'll do some exploration of maps and what's in a map, and we'll talk about a lot of maps. And then get into a little bit of the research that I did on the Tan Brook, a little mini tour of the watershed that we conducted with my students. And then I'll move into some more historical bits about telling stories about the Tan Brook, past, present, and future, as we move out into what's possible for the Tan Brook at the end. So starting with how I got acquainted with the Tan Brook, in October of 2021, I was approached by the town wetland administrator, and she asked, is there a definitive way to measure the flow in the Tan Brook? And I said, sure, that's easy. You take a flow meter and you go out there and you measure how much water moves past a certain point per time, and then you can develop a relationship between the height of the water and that flow rate, and then you can predict it over time by just measuring the water level. And she said, could you do that in the Tan Brook? We have a property that, she didn't give me a lot of information. I just said, sure, we'll do that, no problem. And on we go. So thus started sort of a really nice collaboration between the town and the gown, I call it. And I really enjoyed being able to do this project from the research perspective, bringing students to do some real research, but where they actually had an impact on the town and provided some resources to the town that the town could use, and everybody was really happy with that relationship. The students felt really gratified that they were doing something that was important for the town. In fact, there's the lady back there who asked me to do it. So there she is. So we installed a gauge where we were measuring flow and developing a rating curve. We measured water level in the stream, and then we compiled these reports that we gave back to Jeff with the town of Amherst. And here's, I scattered some little links at the bottom of some of these slides to where those reports are. Don't worry about that. There'll be a slide at the very end that has all of those listed out. But if you go to the Town of Amherst website, all of these reports that we did for the town are there. So here's a little photo group of the various students that worked on this project out there measuring flow in the Tan Brook. There's me by myself on the bottom, and then I have students in the winter and in the spring, and various semesters measuring there at our gauge site as we're developing our rating curve. And then the right two photos are at the campus pond at UMass, and then the lower one there is at the high school. And it's really great for the students to be able to make a meaningful applied research that means something to their community. So they really enjoyed doing this project and would sign up for it every semester that I asked them to. So we were developing stream flow and a rating curve, and so this is a little bit what this looks like. So the plot on the upper left is a cross section. So that's as if you were standing in the water and looking through the water upstream. You would see that the stream bed had this shape, and so it's very steep on the left-hand side, just like it is in the photo on the bottom left, and then it's more gentle on the right-hand side. And each time we measure it over and over again, it has exactly that same shape. So that means that the rocks aren't moving, they're staying in the same place. So that also means that when we just measure the level of the water going up and down, it's a very good indication of how much flow is moving through there, because nothing's changing. We can talk about whether it's a good idea or a bad idea that the stream bed doesn't move at all, but the fact that it doesn't move at all makes it really easy for us to calibrate our measurements. So then we developed the rating curve on the right, which relates the height of the water to the amount of flow. So we measure a volume per time and calibrate those measurements. And then we develop a relationship between the water height and the flow rate. And then that bottom right photo is about the highest flow that we measured. The bottom left is about the lowest flow that we measured. And then between there, we have a pretty good idea of what flow is. We have a wild guess when we're outside that range. Not that wild, but it's not calibrated once we get outside that range. But inside that range, we have a really good idea of what that looks like. So then what we can do is we can take water level that we're measuring every 15 minutes over time, and we can apply that equation and turn that into a flow rate every 15 minutes over time as an estimate. And so the water levels are shown there in blue. The stream flow, or the volume per time, is shown in gray. And all of our measurements are the individual either triangles or round dots. And you can see that the highest round dot is definitely not the highest flow that we see in the Tan Brook. It would be nearly impossible for me to get out there at the peak moment, and I'll show you why, to measure the flow at that time. But we did our best, and so we have a pretty good rating curve. And what you can see is that the flow and the water level don't really change that much over time in the Tan Brook. It stays fairly constant, but you have these really huge spikes that happen from time to time. And we'll look at that a little bit more in a minute. Oh yeah, the blank spot is missing data.
Oh.
So
It's not intermittent.
no, it's not intermittent by any stretch. That's October and November, so there's plenty of flow there. In fact, I had, based on the rainfall records, plenty of information to have a really good guess at what I thought the water level in Tan Brook would be. So you can see I put in some green data, which is my best guess. It's an educated guess, based on some assumptions to what the water level would be. But I didn't even calculate stream flow there, because that would be highly conjecture. Yeah.
Did I miss it, or what's the orange?
Oh, and the orange is temperature. Thank you. Yeah. So I'll come back to that as well. But we also our logger also measures temperature in there, and that can be interesting. In an urban stream, we might see some things there. I goofed with my logger, and I accidentally erased a little bit of data, so sadly was missing a little chunk. All right, so let's, I want to construct a map. So let's start out with what's in a map. So here again is just the shape, it's just the trace of where the surface stream flow would be, in a little bit my imagining of what the Tan Brook was before any of us came around and started manipulating it. It goes around that hill, coming south and then west again as it heads on into the Mill River and then out to the Connecticut. In a lot of ways, a lot of these compiled maps over time is the history of this brook and how it has changed over time. So I thought we could start there. So this is my ideal stream, and this is more or less what the trace looks like now. You can see that from here to here, things get a lot straighter, and there's a campus pond there now in the middle. There's some connectors and things. You have the river splits and comes back together, but not by its own volition. So there's that. Wildwood. Yes, I will be getting there. That's the top right up there. So what I thought I'd do is I'd start out with just sort of a standard looking map. And so for people to get a sense of the map area that I'm looking at, this is going to be exactly the same map area for the next whole bunch of maps. But I'm going to give you some different views of things from here. So this is kind of a standard navigational map. You can see the main roads through Amherst Center, North Pleasant Street, College Street, etc. And where the schools are there. Let's see if I can point at that. That one? Oh, I can point at that. So here's there's the fields for the high school, and there's the fields for the middle school. And so we're starting up here at that pond just off of Strong Street. All right, and so then this is a different kind of base map, and this one does a little bit more to highlight natural areas or green areas on it. It's a different kind of base map, same area, but you can see some of those green areas kind of pop out a little bit more and less emphasis on the buildings and so forth. And so this base map, I've now drawn on top of it that same channel of how the stream is now. So this watershed that I have here is the watershed starting at Fearing Street and going up. It's about half a square mile, and then the rest of the watershed is down here as you enter UMass. There it splits and goes down into those two different pathways. So just to give you an idea of where we were measuring stream flow and how much that comprised. And now this is another map that has even less on it, but in some ways a lot more on it. I don't know if anybody's looked at this map before. So this is a LiDAR map. So this is an digital elevation model created from light detection and ranging, flown from an aircraft. And we have this for the entire state of Massachusetts. These are so much fun to look at.
Are those lasers?
Well, it's a laser from a plane, yeah. So each time it bounces off the ground surface, it creates a point, and then those points are conjured together in a digital elevation model. And for somebody who grew up out west, where you can look out and see the mountains, and you can see out the geography, standing in a forest and saying, "Where is it? I can't see anything." This LiDAR lets me see through the trees, and I can see the ground, and I can see all these things. So there's a lot of things that you can pick up on this map that will become even more obvious when I hit the geologic map next. But for example, you can see these little bumps up here. Those are sand dunes. You can see some of these drumlins here, these rock outcrops that come along through the middle of Amherst.
Where are those sand dunes?
Those are out in Hadley. So, and this is Route 116. That's pretty obvious.
That's the stadium.
Yep, that's McGurk.
Yeah.
Out there. And you can also see, if you look at all these wonderful little meanders where the Mill River has a little bit of room to meander around. You can really see those clearly on this kind of map. So that's fun. And then anywhere where we've put in some fill and flatten things out, you can see those kinds of places too, really clearly. Like here where the sports fields are for the middle school, some of those places really pop out. The Mill River up here where it carves into that canyon, you can really see that. This is a road, right that there. All those roadways really pop out. So then if you put the geology on top of that, what you see is that those high points are covered with old glacial till, and then there's or rather that's the younger till, and then the older till is down below here in the lighter green, and then some of these really permeable layers, stratified drift, various glacial stratified drift are here in orange, and then the yellow is the alluvium from the river systems, and there's our dunes mapped out, and then these weird brown patches are anthropogenic fill. That's something that we put there. So anything, it's just not classified geologically, it's just wonk, it's fill. It's just mapped like that.
Those the brown spots that you see on the map?
Yeah, the brown spots, those are fill. And then the other bit that's kind of interesting here is this blue, the sea of blue. Anybody know what the sea of blue is? Yes, absolutely right. Yeah, so that's the glacial clay. So that's a really thick deposit of these glacial clays that were in the bottom of Lake Hitchcock. It's the thickest, longest record of those clays anywhere in the valley is right around here. So, what was it? What?
Purple.
Purple. That's wetland, I think. Those are like swamps and wetlands. Is the purple. And there is a little swamp. Yeah, actually, there's two of them. There's one, or yeah, right up in there. That's the headwaters for the Mill River up in here. That little swamp going out that way. Not sure. So then, if I draw the river channel on top of this, now it sort of makes sense where the Tan Brook goes. So its natural channel kind of goes up here, starting in this valley. Drift comes down off the till, comes across some more of the glacial stratified drift, and anywhere here where they've filled in for the sports fields, it moves its way around, and then comes across to campus. It picks up some of that. Some of this alluvium was probably original Tan Brook alluvium. This is another routing that was added later. Yeah. Oh, Fearing Street. Yeah. So Fearing Street is right around here somewhere. Just before that, so the split is just down from that, so Fearing must be right in there somewhere. So then you should be able to see it now. Now this is a messy map. This has like all sorts of things on it. So we've got a USGS topographic map with the contours of elevation. We have the blocks for all of the buildings. We have the stream channel that I drew in place. We have the geology. We have that surface elevation. But if you really wanted to see all those things overlaid, it's kind of helpful to look at them all at once if you can not go cross-eyed doing it. But we got here from somewhere, and so this was part of what I wanted to do, is both build up a complicated map, but also shrink back down and make it less complicated and then get complicated again. So we're going to go back in time to the oldest map that I had, which may not be the oldest map that exists out there, so some of you will probably know whether it is or not. So again, this is the exact same map area. And when I don't have a map that's large enough, I just paste it onto that LiDAR shading so you can see where we are. So this one is from 1833. And so you can see the Triangle Street crossing there and the basic trace of the river. And I'll say in the oldest of these maps, they didn't map every single little meander. So even if they were there, they didn't draw the maps that way. And sometimes they would draw little wiggles for a river, even if they weren't the exact meanders of the river. So with a little creative license, know that it's probably smoothed by the draftsman, not necessarily that the river wasn't meandering, because if anything, it would have been meandering more before we straightened it. So here we are back then. So it's only taking this one path down to the Mill River there. This next map is from 1873, and now we have mapped in some of the historic homes in town, and these are fun because they have all the names on them of who owned the home from some of those places. And now we wind through, so we've got, now we can see Fearing Street, I think, in here, going through town in McClellan. It's not under Kendrick Park yet. It still meanders around and swoops over towards McClellan at this time. 1903, I think, is the same, and this one is over a soils map. Not this isn't the surficial geology, although they track because the soil that's on top of the rocks looks a lot like the rock underneath it, understandably. So this one shows that similar trace. You can see Kendrick Park now in there, kind of swooping around in there. And then we get to 1941, and now this is the first map, I think, where the Tan Brook disappears from these surface maps. So this must have been the time, somewhere between 1903 and 1941 must have been the time when it gets put in the pipes and shoved underground. We now have the campus pond is clearly on the map at UMass, which I guess is still a Mass Aggie at that time. And then we have this nice straight bit in through here where we're just draining out through the bottom end of campus there. And that's probably still on, that bit is still on the surface, but not for long. And the other thing to notice that's missing from this map that I wanted to point out here is not only is the Tan Brook absent from the surface up in this region, but the other thing that isn't over here is Route 116 still isn't there. So and this one has a lovely map of all the meanders of the Mill River. So when UMass complains about the flooding around 116, you can know that the reason why it wants to flood is because it wants to be a floodplain. It was a floodplain for this river that goes back and forth across the floodplain, and it's very wet and swampy down there. And lovely in my opinion, but that's what's missing from that map. All right, so then there are other kinds of maps that might highlight specific landscape features. And when I start to talk about some of the future ideas for Tan Brook, these maps will come into play because landscape architects will make different kinds of maps that highlight different features to really show one particular thing over another. So this was from work by a gentleman named Todd Lynch from 2009 landscape architecture thesis, which was really prescient in its time, and I'll show you some more from it, and I think some of you will really like what he did in his analysis. And I think that a lot of these theses could be used for thinking about planning and design. They do some really great work. So he did some analysis here, but this particular map is showing places where water can soak into the ground or pervious surfaces, and also tree cover. So the trees, I think, are shown in dark green, and the soil, open soil or grass or whatever, is shown in light green. And then the black is all of the buildings and streets on there. And then if you were to color them by just parking lots, for example, these are just the UMass and Town of Amherst parking lots. And I suppose this is as good a place as any to mention that the little water, we just did the analysis on that little watershed that I showed in the previous picture, but of that tiny little watershed, 30% of it is paved or rooftop. That's a lot. That's huge. It's massive. At 5%, the stream already starts to see impacts from that, and this is like 30. So it's quite a lot of pavement in our little itty bitty creek in our little bitty town. So here's highlighting some of those features. Does anybody know? This is sort of a weird thing. Like normally, if you have a watershed at a point and you say, all right, this is where the Tan Brook flows into the Mill River at this point, then upstream of there we have one watershed. And the Tan Brook is funny because it not only has not just one, not two, but actually 3 different places where it goes into the Mill River. So one of those is this northern entry here. The southern one is down here. And then what's happening here that's not even mapped in the watershed? Does anybody know why that looks like that?
Is it the playing fields?
It is the playing fields, but why doesn't it count as part of the watershed? It is part of the watershed, right?
Water?
Say again?
It's all swampy and so it's not in the
I mean, the fields are, they're sitting on a big pile of clay, so water doesn't like to drain off, but water doesn't like to drain off, so UMass did something about it.
Oh, is that where they put the thermal things?
Oh no, that's further up on the, higher up on campus, that's very cool, but not quite there. So, but they did do a lot of underground infrastructure and piping and drainage. So basically what happens with these fields, when they renovated these fields, they put in a bunch of drainage pipes, and it drains directly to the sewage treatment, and then it goes into the Mill River. So it actually is kind of completely extracted from the watershed. It's a good thing, because they're cleaning up the water and the nutrients and whatnot from the sports fields before they get in there. But that's why there's that hole in this watershed map, which is a little funny. And then this is another picture from a thesis from 2016, giving you all of the, if you squint at that, you can see all of those little tiny blue lines and dots. Every single one of those is either a little catch basin where water can drain in from the street, or a pipe that connects that to another pipe that connects to another pipe and eventually ends up in this whole drainage network. So suffice it to say, this is an extremely urbanized little stream once it's on UMass campus, for sure. And here's that weird split, which they're in the process of renovating because it causes all sorts of trouble. Here's another, one last map, which is another map of the whole watershed, calculating that out in some of the drainages. So in this one, they're highlighting these big main red drainage lines where the Tan Brook is underground, and then the above ground bits are this little teeny bit back behind the high school. So there's the high school there, and the fields, and then there's that little bit in the woods. And then this section, which is the prettiest section of the whole Tan Brook, right in there through the neighborhood. This section was prettier until they put a giant high-rise next to it. And put the fence right up next to the river. And now they've got, and then this is the split, and now we just go basically underground. This section here, which is essentially a drainage ditch, has potential. There might be some potential over here too, where that's above ground. All right, so now going back, to, we'll do a little watershed tour. So we'll do a little photo tour moving from top to bottom down the watershed. So this was one of the first projects that we did with my students is to figure out where is it. So I guess Barbara, you already did this. So let's see if we agree about where it goes. But this is what we thought we found. So one of the points of dispute about where to draw the edge of this watershed was, where does it start? What's the highest point? And it sort of starts in this swale. There's a swale here in between these two high points, and there's this kind of marshy area. And at some point, some of that water drains north into the mill, and some of it drains south into the Tan Brook. And the only reason the water drains south into the Tan Brook, or the main reason, is because, well, there's this road here, Strong Street, which is higher than this midpoint. And the reason why water drains through it is because, well, there's a pipe there. So you put a pipe in, and water's going to drain downhill, so down it goes. So this is when we were in the most recent drought. It dried out, and that pipe wasn't doing anything, but that's what it looks like. And so here's the pond up there. It's up above Strong Street. There's the pipe going down to Wildwood Elementary. So then moving downstream, now we are in the middle school. And this is kind of interesting because there's a pipe that goes under these fields, but there's also this ditch where there's a little bit of surface flow also. And then it goes into a grate here. It goes down in. And then here we are at the high school. I skipped a big section in the middle there, but we explored that middle section too, where there's various street drains, and there's another sort of swale along the side of a neighborhood. And actually, I think some of that area is kind of still wild area. And then back in here, this is the ditch that runs along the back behind the high school. Here, there you can see the high school. This is from the end of it. And then you turn, and there's that culvert where it goes underneath the high school fields there. And then, somewhere, I can't remember where this one is actually. I think this is up here somewhere. But this is kind of cool. So when you're looking at the LiDAR imagery, you can see things. You can see elevation features that you wouldn't necessarily pick up, and this is one that really pops out of this map. There's this weird little hole in the elevation there, and that hole, a little stripe, that's the little ditch in Garcia's parking lot, which is that one that may have once had a sign on it that said the Tan Brook, but that's that last little bit. And here it is on sort of a sad, dry day.
That's across from Kendrick.
Yeah, across from Kendrick Park, back behind the old Bertucci's, the now Garcia's parking lot. Spoke, as the UMass students will all know. They probably stand there all night in line waiting to get into the bar. And then from there we go across, under the parking lot, under Kendrick Park, under McClellan Street here. So we come, there it is there, we come down across through here and under the street. And then right in here you can see there's another big elevation drop. This is where that culvert opens up into the really nice section downstream of there. So there's McClellan, here's between McClellan and Fearing is that really nice section, and you can see that on all the maps there. So this is looking at that from downstream. So it's a pretty big, it's a 9-foot culvert or something built in 78. This is looking down from it. It's looking up towards it, and this is looking in it. So there's another. This is probably the one that comes from the high school that comes into that big tunnel. That's as far as my student went in to take that picture. And now we get, and then I've jumped over the Fearing Street area because I had some other photos of that earlier. This is the very last daylighted section at UMass. So this is, there's 2 pipes that come out of here somewhere. Those are right right here, just below Commonwealth Ave, these two pipes pop out, and they're pretty big. Look, there's my students for scale. Some of us are very fond of this section of the stream because it's a really nice exposure of the varved clays from Lake Hitchcock. So if you're feeling intrepid and want to go down into that, it's quite an eroded, incised bit of channel there. But if you walk down in it, you can see a really nice exposure of these varved clays right there on the side of the river. But generally the water quality is not great in here. There's some funky stuff that's coming from, I don't know, some fill maybe in those parking lots. Whatever was used to fill in and level out those areas that became parking lot 12. There are rumors about what's in that stuff. Nobody really knows, but when it leaches out the side of the stream bed, it doesn't look so great. And actually the facilities folks at UMass have been talking more and more about trying to do some sort of remediation there, or maybe a kind of biofiltration, something or rather down there to try to address some of that before it goes into the Mill River. So just down from here, this section gets pretty wild and overgrown and incised, but just downstream of that, it goes into the Mill River and it gets a little bit more wild. All right, so telling some stories about Tan Brook and over time. So one of these stories, and I don't know if this is true, but I came across this at a sustainability event, says that the Tan Brook was originally dammed by two students in 1891 that formed what became the campus pond. Now, according to my maps, by 1903, I still didn't see a campus pond, but you never know, maybe there was a little puddle there. So the story goes. And then this one I really loved because I think some of you must have read my little story in the Hampshire Gazette about the Tan Brook, and this is Fearing Street when the water's flowing over it at November of 21. And that happened subsequently several more times, but we just got photos of it on this time. And some of the way that I thought about the stream at that time, and as I was doing some research for that write-up, I came across this. One of the neighbors gave me this article. Let's see, when is this one? 1972. And Mildred Dickinson wrote this article where she was talking about remembering having grown up next to the brook and having it be incorporated in her classes at the various Amherst schools as a young person. And there's a photo of her class after they went out and caught butterflies and frogs and what have you in the stream, which I just love. And I just thought it was so great because having the stream that goes right through and literally winds from the elementary to the middle school to the high school to the university is such a cool trajectory for the education in this town and also the flow of the river. And I just thought it was fun that it used to be connected in that way, and why couldn't it be reconnected in that way? And there's some potential for that. So I kind of planned some of that same wistful thinking that perhaps history could repeat itself if we did that again. So here's a couple of highlights from a couple of those reports that I gave to the town, showing a couple of things. So I mentioned that mostly the flow in Tan Brook doesn't change all that much. It's a fairly uniform, not very high flow. It's a pretty small watershed, but because of all of that pavement, when it rains, it really spikes up fast. So I told you I collect data every 15 minutes. So the difference between the dots is 15 minutes in time. And you can see that in two dots, that one storm, this is that November 2021 storm, it jumped up 1.5 meters. And so for a brook that's usually flowing at about this deep, it was about this deep in 30 minutes or less. So that's a really, really fast response time. And the only reason that stream can respond that fast is that the pavement immediately dumps the water straight into the river and it just jumps straight up. And so it accumulates really fast. And then our ability to estimate exactly what that flow rate is a little bit tricky. And part of the reason why is because, again, it changes so fast. So in one June storm, I ran out there when it was raining and ran into the river and tried to measure it. And this is what I got. So this is my measurement for the flow. And while I was measuring, the level of the river changed that much based on my observations. And then the blue curve is what my logger was measuring at the same time. So you know, it's a pretty good approximation, but when it's changing that much, you know, again, there's bigger errors on it. And then finally, that temperature record that we collect, we also see that if it's warm out and the sun's been on the pavement, we know that the water's coming straight off the pavement because the water's really warm. And so not only do you see the water jump up in the stream, you see the temperature jump up in the stream at the same time. So you can see that in this storm here, and you can see it in these storms here where you get a spike of flow, and you also get a spike in the temperature that's higher than what it was doing just daily, going up and down.
Does the temperature changes the ecosystem of the river, having, you know, this so much warm water jump into the flow?
Yeah, because a lot of the creatures that live in rivers really like it colder. And across western Massachusetts, we do pretty well with cold water streams, where a lot of the streams are cool enough for a lot of the species that like the cold water, but not when it's urban like this and when it gets really hot. I doubt there are migratory fishes in the Tan Brook, but we've seen fish and we've seen frogs, and there are still living things in there, but no, they don't particularly like it, and that you hit lethal limits for these creatures when it gets too hot.
Things live in the Mill River.
Probably more, yeah, because it's a little bit.
Story River, is not so much.
Not so much, yeah. It's a much more free-flowing river. If there are those kinds of creatures that live in the Mill River, because the Mill River is a little bit less urban, a much less urban watershed.
How long does it take the water to dissipate? If it went up a meter in a half an hour, how long does it take to go down?
Well, it's almost back to normal in about an hour and a half. So very fast.
Yeah, flash flood.
Yeah, very flashy. And that was just about, not the highest, but just about the highest flow or water level that we measured. All right, so where am I? So now I'm going to head into the future of Tan Brook, thinking about the future. So this is one of my favorite spots on Tan Brook, back there in the section in the back. And I just, I just think that we could make better use of some of these theses, and both the students who have done these theses as well as some of the folks in facilities at UMass for the properties that are on UMass that they're working on. They like the idea of talking to the academics. And wouldn't it be cool to have a sign up there that said, this project was designed by UMass students, and here it is at UMass? I think that would be great. They like that kind of thing. But here's one from the high school. So this is from that project I was telling you about that Todd Lynch was working on. And I really like what he did here, because he really took advantage of this sort of forgotten wild section back in here from the high school. And so he looked at some of the circulation patterns, and he added some pathways and ways for people to get around and experience the creek and interact with it. He has this whole garden area in here with walkways and things, and then does some restoration to the waterway in here, improving that wetland habitat, and then does some kind of educational gardening, rain garden type of things in front of the high school there to have a more interactive thing. So he calls this the birch gathering spot and the poetry walk that go in through there, and has some pieces in there tying into the history of the town, and then this boardwalk area. So having back into the wetland there, having a boardwalk along behind so that you can really commune with nature when you're back far from the high school, and have that kind of restored area.
Yeah, Tan Brook goes under the high school.
Tan Brook goes not exactly under the high school. It goes behind the high school and under the high school fields.
Oh.
And it comes out behind those houses
Yeah.
on, is that, cottage?
There's Cottage and Ames Place back there.
That's down on the river. It goes to High Street, but it's not High Street too. It's the street that becomes High Street.
Right. What is the name of that one?
Chestnut.
Chestnut. Yeah.
About 7 or 8 houses.
Yeah, and then, but to the east of those houses, there's also kind of a place where its flow could be restored a bit more into that swale maybe, and this kind of idea continued in there. So this was another thesis from 2016, and this student was trying to see where are places where we could decrease the amount of pavement and try to process some more of that wastewater on site. So this was looking at Haggis Mall out in front of the Fine Arts Center there, and she was thinking of sort of bioretention thing or routing a stormwater through a kind of a stormwater garden structure. So this was her rendering of that. And just kind of a cool thing, you know, more green space, more processing right there in situ. And then this was one from 2015. This is probably UMass's biggest headache with the Tan Brook is this drainage down here. And part of what happens, so this spot is, they call it the West Gate. It's right down there where University Drive runs into the sports fields, and then you turn right, and it's where that overflow comes down. So they send some of the water straight across Commonwealth Ave into the campus, under Haggis Mall and into the campus pond. And then what doesn't fit through that pipe overflows and comes down here to this part, and it's really unpredictable. It's flashy, as we know. It comes in these pulses that come a lot all at once straight off the pavement, and they come roaring down here and rip up that kind of swale that they have between the sports fields. And so there's some ideas about what to, and they get clogged all the time. So here's some of the guys cleaning out the stuff that's clogged in there. They put up these kind of storm fences. I'm not sure what the purpose of those are, but they're not doing so well. They get eroded and fall down, and it's making this head cut that's just carving through that material because it's essentially, you know, grass sitting there in the swale and dirt sitting on top of clay, which is nice and slippery, so it just wants to slip right off. And so here's this area when it's flooded, so it kind of, you know, makes a little river. But you could do things with that are prettier and that are more functional, but that still allow people to. The other thing is it has to be ADA compliant, and you have to be able to get people over to the sports fields. And sometimes you have a big event and you get a lot of people walking over there. So it can't just be, you know, a bunch of rocks that they're going to trip on. But what could it be? And I like this design here. This is a thesis from 2015. Nathan Frazee did this whole design. Apparently the roundabout there is already in the master plan for UMass. And so the idea would be to do some more erosion control up at the north end of that, and then have these bridges that you could take over this little swale stream setting. And then the swale and stream is kind of more like a rain garden approach, where it's more beautified. There's some roughness in there to slow down that flow and keep the erosion at bay. And I think they're currently thinking about this and working on this now. And I said, well, would you let a pesky academic come and talk to the consultant and, you know, just throw some ideas at them? They seem amenable to it, so we'll see what happens. I'll do my best. And this is one of the ideas for what those bridges might look like. This is one that probably wouldn't be compliant, but is pretty. So if you have these kind of blocks that decrease until you get to a center point, when it's flooding, it just goes up over those. But when it's not, you can hop right over that. Those are kind of nice. And there are other kinds of rain gardens and things. That photo on the right, I think, is actually from Lot 62 at UMass before they took it out when they put in the design building. And they built another rain garden that didn't work nearly as well as this very simple one. Which this one was designed by one of the UMass classes, one of the building and construction classes designed that one and built it. So you never know. Anyway, here's some whole list of references which I'm sure you'll be provided with later, and you can get into those where all those theses are. And then I'm open to any more questions as we continue. Thank you so much for listening.
What is the water quality? You said it was poor after it goes through the UMass. What about this area?
I believe there's still some issues with E. coli from time to time. I don't know how often that happens. That's something we're looking into doing some more sampling on and trying to quantify that. There's been an effort to do some phosphorus sampling up in there, and it's variable and a little. It's not just a seasonal thing. There's so many different inputs that could. Phosphorus is a tricky one to track because it can change with residence time in the stream and different inputs. And if you wash your car, you dump a bunch of phosphorus in the stream or whatever happens. So it's a little hard to pinpoint causes there. If it's warmer, you might get a higher number. So we're trying to pinpoint some of that. we did one campaign where we went through and looked at some dissolved solids, so salts and things like that with conductivity and pH. It's sort of ongoing. It's the kind of thing that's really easy to do with a group of students, is just to go along and measure these things kind of periodically. So we'll work on that some more. I know that several of the consultants over time, as they were doing various projects, had done some of these measurements and found it to be suboptimal, but I don't know more than that. There was one DEP report that was put together for Lake Warner, and that one contains a lot of the data that are published for that.
So you mentioned the tannery. What
Oh,
other
yeah.
sources of pollution are today in town, dumping into
Well,
this
historic,
area?
because the tannery was what gave the brook its name. There also was a gas station in town, and who knows if some leftovers from the gas station end up in the soil and are being picked up in the watershed over time. I don't know what the history of septic treatment in the town has been, is, but presumably some of that older nutrient load could be a historic contaminant. And then anything that's on the surface of the streets. So that could be oil from cars, dust from your brakes, anything that wears down in a car ends up on the road. If it ends up on the road, it ends up in the road. Do you know that, Erin?
I don't, what is it?
Where is the tannery, is the question.
Oh, the tannery would have been on the east side of what is now Kendrick Park. And it was operational through at least the 1820s. I don't remember the name.
So, like-
There was more than one generation.
Where
of
are
people who were tanners.
Like,
There was a whole mechanical area at the north end of Kendrick Park in the early 19th century with cordwainers, various people in the mechanical trade. And this is, of course, just north of the village, so it's sort of the low end of the history of industry. The tannery being first.
Okay.
From time to time, there have been instances where developers or residents who construction projects have had to apply to the Conservation Commission, and they've evaluated, they brought in consultants, either the residents or the town, to determine whether the stream was a binary conclusion. If it's intermittent or not, does that would affect how much development can happen? Do you know the history of these findings?
There's somebody here who could comment on that better than I can, but what I can tell you is from my measurements, the Tan Brook never stopped flowing, even when we were in a stage 3 drought in town. So to me, that's enough evidence to say that it's perennial and it is not intermittent and it doesn't stop flowing. It also, by all of the other metrics that you make that are related to flow, it has to be, it's 5% threshold level of flow has to be above a certain amount, and we're well above that. We're at least twice that. So, I would say perennial based on the hydrology.
And is the town aware of this at the governmental level, the committees that look into this? Do they understand that?
They are, and as far as I can tell, the Conservation Commission is very interested in conservation, and they're really trying to conserve the resource as best they can.
I was always curious when we were measuring the upstream flow, being measured, but it was being measured, and whether there was a half a mile or whatever. It always seemed weird. I could see the pond, and I could see that some of the stuff would flow back toward the mill. But there's a hill on one side. I mean, where does that, doesn't that water go into that pond?
Yeah, so that's like when you look at I can show you that little watershed.
I mean, it's a steep hill.
It is.
It's
So when you look at this one, these little points, that's the hill. So this is the water that flows, here's the pond, and this is the water that flows into that pond, and then this water flows into that pond over there.
But I got the impression that the maps that were available said that the Canada storm at
Some of them have it starting at Strong Street, which is a higher point. This point is higher. This is higher than this.
than the pond. But
Right.
the pond is downhill.
That's right. And so if that pipe weren't there, it wouldn't do it. And actually what's interesting is that the USGS Stream Stats program, which is hydrologically accurate, and they map all these things, they're starting to incorporate sewerage and drainage systems and all of these kinds of features, because they totally change what the outline of the watershed should be, because they're connecting places that weren't connected, or they're disconnecting places that were, and so they have to incorporate that in order to accurately determine these things now. So that's a work in progress, but it is starting, and it was something that a case that had to be made for drawing the watershed line where you draw it, because we know that pipe's there. It's the town of Amherst's maps are much better even than the maps I've showed you here. They're much more detailed, and they have all of where those sewer lines go and everything. You can follow every single one if you want to, and know exactly where they go. And then you can say, okay, if I know that there's a drainage catch basin here, then this is the area that's captured by this catch basin. All this has to be now included into that watershed, because I know if it rains in this place, it goes into that catch basin and it goes into my river.
If anybody else has a question, I have another.
Christine?
Yeah.
I've only lived in Amherst for 5 or 6 years, but even in the time I've lived here, I've noticed the water behaving differently in the Tan Brook area, let's put it like that. And I wonder if you could just comment for all of us here a little bit about how you see the climate change that's going on impacting the way that particular area might look and feel, 20 years from now, 15 years from now?
I guess one of the big changes that we're seeing play out more is what we call an intensification of the hydrologic cycle. So when you have a rainstorm and it's warmer, that exact same rainstorm with the exact same physics suddenly has more water in it, because the warm air can carry more water. So if if everything else is created equal and the storm is exactly the same, that storm will now have 5 inches of rain instead of 2. And that makes a big difference when that storm occurs over a period of a few minutes or a few hours or even a day, because all that water falls at once. And so it can do things like land bigger drops on the crops and start to destroy crops just because it's that much more intense. Or it can land on your street and go into your very urban stream, and the water level kicks up a lot. So one of the other things that we measured was they do estimates of how often a flow of a certain size should occur. And I have like now 2 years of data. I don't have 100 years of data, so I can't tell you what the 1% chance of something is, because I don't have that much data. So what I can do is I can say, well, based on these guesses, these are the sizes of flows that we should see at this interval. And so if I pick a threshold and I say, all right, what's the amount that I ought to see every 10 years? I saw that level of flow 10 times in 1 year. And so that's kind of evidence of that exact same phenomenon happening, which is, possibly what you've seen. I mean, certainly July 2021 and July 2023 were ridiculously wet. And we saw lots and lots of rain, and we saw a lot of these really kinds of intense storms. And that is one of the kinds of things that I think we're going to see more of.
Thank you.
I would just add to that answer to that question, think about the construction in downtown Amherst as well. How much additional impervious and additional, large buildings and things have been added where previously. It would be interesting to look at, in the last 5 years, the additional impervious surface that's been added downtown.
Yeah.
To also, in addition to what you're talking about, with increased flows, now we've got more impervious surface.
That's right. And that'll just keep making it worse.
I wondered whether the university is missing an opportunity at the pond to do some remediation of the water quality law.
I don't know, the pond is environmental health and safety's worst nightmare, always, because of the sediment, because of the pathogens, because of the birds, you know, you name it, it's there, and I mean,
Well, those weeds.
yeah, so,
But then before it goes to the river in Connecticut, it does have that long sort of swampy area
that's right.
could
Well, and, you know, the pond is, you know, it's this park-like, beautiful thing that people like to look at just the way it is, but I think a lot of these bioremediation park kinds of things or rain gardens can be really beautiful. And I think they're nice, and I think we could do both. And I think having some of those things in very public places to say, UMass cares about this, and we're treating the water right here, and our students designed this, I think that would be really great, and it would send the right message.
Well, like there's three actually, new, next to there's that garden that comes down next to the design building.
Yep,
They put one in Moral,
Moral, yep.
and then alongside, the big science building.
Oh, that one's fake.
That one's fake?
That one makes me very sad. Yeah, that one's, it's beautiful, and there's a pipe underneath it.
Oh.
Sorry to disappoint. I know, I ruined that one for you. The one by Moral is good, and it actually goes off when it's raining hard. You can see the rain garden doing its thing. The design building one is good and beautiful, too small, doesn't quite function that well. Crotty Hall has a good one. Crotty,
Oh, right.
right next,
Yeah.
near Kendrick Park, much closer to Kendrick Park. Yeah, that one works and it's nice. Can be done. And actually, some of the ones down by the dining commons by Berkshire, they're kind of these sunken, interesting rain garden things. Those are quite effective, actually. Some of those are pretty good.
Sounds like another walking tour.
Yeah.
Thank you so much.
Thanks again for having me.